Hey peeps, today we're learning about calculating the energy for a reaction, like how much energy will be released to make it hot or how much energy will be absorbed to make it cold, just using a balanced chemical equation. So you can use these energy values called standard enthalpies of formation. The symbol is delta H sub F, and then there's a little circle in the top right, kind of like a degree sign. That means standard conditions. So enthalpy just means heat at constant pressure. The constant pressure isn't really that important. It just means that it's not in a closed container, and that makes work not a big deal, so you can do calculations easier. So delta H is a symbol for enthalpy, so heat enthalpy. And it's defined to be enthalpy to form 1 mole of a chemical from its elements when they're in their standard states. So standard states means standard 25 degrees Celsius, 1 atmosphere pressure, and 1 molar concentration. So notice it's not STP, it's standard states. For example, what would be the equation for the energy to form 1 mole of CO2 from its elements? That's delta HF. So we're going to say, well, CO2 is made out of carbon and oxygen. Carbon comes as a solid and just one of them. Oxygen comes as a gas and it's diatomic at 25 degrees Celsius and 1 atmosphere. And it makes CO2 and is balanced. Next one, C2H6O, that's ethanol. So we're going to have carbon and hydrogen and oxygen. So carbon, hydrogen needs to be diatomic, because that's how it comes naturally at 25 degrees Celsius. Oxygen, diatomic. And then we've got to balance it with numbers that make the coefficient over here turn out to be 1. So then we have to put a half there. So that's kind of strange. We don't usually do that because we like whole numbers, because you can't actually have half of a molecule, but you can have half of a mole of molecules, so it works. And because of the definition of being 1 mole, we've got to do that. We got to do that and make sure it turns out 1 mole. Okay, another example, aluminum oxide. So that'd be aluminum and oxygen. So then when we balance it, we've got to double that one. And the only way to make the oxygen turn out to be 3 is to use 1.5. We can't change this coefficient because the definition says 1 mole. Okay, so then what we calculate with those is just with the math equation. It's on your equation sheet. The heat for the whole reaction is the sum of the moles of the products times their heats minus the sum of the moles of the reactants times their heats. Sorry about the bell. And then this is kind of silly, but this shows up a lot on the AP test because they like to trick you for stuff. The enthalpy of formation for an element would be, well, definition is form 1 mole from its elements so forming an element from an element is no work at all, so that would be 0. For other values, you can find them in the back of your book on page A19. Here's an example with numbers. Calculate heat for the reaction C2H5OH liquid plus 3O2 gas forms 2CO2 gas plus 3H2O gas. So we're going to do coefficients times the heats of formation for the products minus coefficients times heat of formation of the reactants. Notice I put all the reactants in brackets so that's subtracting all of them. And then you look up those values on page A19. If it was a test or a AP test problem, then they probably would not give you this one. In fact, they might not even have that one in the back of the book, I'm not sure. That's because that's an element, so energy to form an element from an element is 0. So you just put in those numbers and you do the math, and you know that O2 is 0. And you wind up with negative 1,235 kilojoules per mole. I'm looking at my sig figs. Looks like I should have 3 sig figs because of these numbers here. That mole there is per mole of reaction. So yeah, I guess I didn't fix the sig figs there on my notes, sorry. So then, one more example. If 100 grams of ethanol releases 2,680 kilojoules of heat when it burns, what is the molar enthalpy of the reaction? So molar enthalpy just means per mole, like this. Per mole of reaction means when you're using this many mole of things. When you're using 1 mole of ethanol and 3 moles of oxygen, and you get 2 and 3, that's 1 mole of the reaction. So I have the heat, that's the enthalpy, and I have a number I can convert to moles, so I just need kilojoules per mole, so I just divide. So I'm going to take my kilojoules, and I'm going to divide by my moles. I'm going to convert to moles using the molar mass. And I know that 1 mole of methanol is used in 1 mole of reaction. If it wasn't 1, then I would need to put a different number there. So this is also 1235 kilojoules per mole. And again, with sig figs, we should still be using 3 sig figs. Actually, on this one, I should have 1 sig fig. Sorry for not having the sig figs right on this one. 1 sig fig from this number. So I would round just to negative 1,000 kilojoules per mole.